Hello, and welcome back to our normally scheduled math lesson. So we talked about a lot of things in this chapter so far. We worked on understanding direct variation a little bit. Today we're going to work on understanding the second half of this section, all about linear functions, graphing these things, understanding what they mean, okay? So remembering that these go through the origin, we know that these are not too hard to graph. We can do these things. So the vocab is the same. We're going to work with that COV, that constant of variation that comes attached to our x. We know slopes going up to the right are positive. Slopes going up to the left are negative. So we have those in our toolbox as we get going here. So we left off here. This is example 3C. We want to use this information to write our equation. So we want to end up with a direct variation equation. And we know y varies directly as x. That just means we're going to write an equation in the form y equals some number times x. Now our goal is to find out what is this some number. What is k? Once we find that, we just substitute it in, write that equation, then we're good to go. So they tell us write the equation when y is 15 and x is 5. So we're given those two things. So in other words, we need to plug those into this equation and solve for the missing k. So when x is 5, y is 15. So we'll get 15 equals some number times x we said is 5. Okay, so some number times 5 equals 15. What does this number have to be? We'll divide both by 5 and see what we get. Over here they cancel out, and on the right we get 15 over 5, which is 3. So k equals 3. So the direct variation equation we would get is y equals 3x. Now they say use this equation that we just found to find out what x would be if y is a negative 45. So now we'll take this value for y, plug it in over here, and see what we get for x. So let's plug that in here. So if y is a 45, what does x have to be? So to get x alone, we need to divide it by 3. So we'll do that both sides. 45 divided by 3 should give us 15, and this is a negative 45. So this is a negative 15, and that is the solution for x. That is our final answer here. We found x. That's what we were asked to do here. So of these choices, we know C is correct. So we're rocking on that one. We figured it out. We're good to go. We can understand this problem. Okay, so the fourth type of example we're going to work through has some real world context for us to think about. So this one is concerning travel. So the Ramirez family, they're driving cross country, going on a vacation. They drive a little more than 300 miles in 5.5 hours. We want to write an equation so that we can find out how far they drove for any number of hours, so that we could have an equation to understand how fast they're driving over time. So our goal is to write this direct variation equation. I'll circle these numbers that are important here, and we'll use those as we continue on. So we know distance is equal to our rate times time. We wrote this in our notes for the last chapter. So distance equals rate times time. So we could write an expression using the distance given, 330, and the time given, 5.5. So we plug those in there, and now we have an equation we can use. 330 equals the rate that we don't know, times the amount of hours that they drove, 5.5 hours. So have that down as we move forward. Okay, so we'll solve this whole thing to get the rate. So we had this equation already. We want to get r alone, so we need to divide both sides by 5.5. So on the left, we're going to get a number, and on the right, we just get r. So when we divide that and simplify, what do we get? Well, the rate is 60. And in terms of this problem, the units for that is 60 miles per hour. So the direct variation equation is our distance equals 60, that's our rate, times t, however much the time is. So we can use this rate now to say how far would they be after 1 hour, 2 hours, 3 hours, 4 hours, anytime we want. We could plug into that and then find out how far they are. So that's the purpose of this equation. Solve for the rate. That's just like k in all of our other equations, and there you have it. D equals 60t. It's the same thing as y equals 60x. It's just different letters since we're talking about a real context here. Okay, so with that in mind, we can now graph that equation. So remembering our equation from the previous step, D equals 60t. We want to graph this whole thing, and we can do that treating d as the y variable and t, our time, as the x, as always. Time is always on the x-axis. So we know all of these are going to pass through the origin. Every direct variation equation will go through the origin. So here we go. Slope is 60. That's our rise over our run. So from the origin, we'll go up, we'll rise 60, and we'll run, we'll go over 1 unit. From the origin, do this and this. That'll give us a second point, and then we can draw that line. So the image that you should draw, if you haven't already, should look like this. So your origin and our second point would be up 60 for our distance and over 1. So we get this point here. And we would plot that and keep the line straight, and that's how we would get this whole arrow here, this direction, that line. Not bad at all. Once you graph it, it's pretty straightforward. They're driving at a constant rate, so you see a linear slope. Line is always the same, and you have a straight line. So make sure your graph looks like this as we move forward. Okay, C. We want to know how many hours would it take if they're going to drive 500 miles. So given what we now know, the distance is equal to 60 times the time for any relationship between these. They tell us now the distance is 500 miles. That's going to be D. Then they ask us how many hours. Hours is what? Time. So they're asking us to plug in a value for D and find out what the time must be. So with just one step, we can plug in. So we had our original. They gave us that 500, so we can plug that in. And now we divide both sides by 60. And on the right, we get just T. On the left, we get an easy number. 8 1/3, or 8.33 hours is how long it would take. And that is easily found using that original equation. So this estimate, 8 1/3 hours, is our solution for 4C. You could estimate at this rate, it's going to take about 8.3 hours. You could say 8 1/3 hours. You could even convert it to minutes, although they did ask for how many hours, but any time measurement that is accurate here would be correct. So leave that as 8.3 hours. That's how long it takes to drive 500 miles, given they're driving 60 miles each hour. All right, have that down as we move on to 4D. So we have some words to jot down, just a couple sentences. So please have that down and get started as we circle what's important. So Dustin is running a 26-mile marathon. Okay, that's how long marathons are. And the time it takes him to run is given here. So we'll call this variable h. And the distance will be here. You say write an equation. Okay, that's our goal. We want to find the distance run for any number of hours. So if he can run a 26-mile marathon in 3 1/4 hours, what is the rate that he's running at? So remember we said distance equals rate times time. So our time for this is in hours, so we can use t or h. So let's rewrite this as distance equals the rate times the number of hours. So now we can plug in the two numbers given. There's 3 unknowns. They give us 2 numbers we could use that go together. And then there'll be one variable left, that is r, the rate. We can find that rate that's always the same, and then that'll help us write our equation. So plug in what we know. D is 26. So let's substitute. D is 26. We don't know our rate. The h is 3 1/4 hours, 3.25. Okay, now we need to divide to get our r alone. So notice here is our r, this is our variable. We want that by itself, so we will get rid of this 3.25 via division. We can cancel this out, and on the left we're going to get a number. So if we divide 26 by 3.25, we would get 8, and that is our rate. So now that we found out what r is, we can go back to our equation here, our blank equation, and we know r has to be 8 at all times, so we can replace this with an 8. So our equation, in the last step, when you replace, it's equal to 8 times h. Distance equals 8 times the number of hours. So, of these options, which one has this written? Well, that's not it, not it, not it. D is our solution. So please have D equals 8h for this problem. Make sure you have the words and the couple steps we use to solve. And our red circle confirms distance equals 8 hours for 4D. Okay, so looking at this, we've got a few options to choose from. They want us to graph the situation that we were just talking about. So we've still got the same equation. So we know D is equal to 8 times the number of hours, okay? So we're going to start at the origin as always, because these are all direct variation problems. So let's check. Do each one of these start where the y and x axis meet in the middle of our graph? Well, yes, this one does. That does too, that's fine. C does as well, but D starts way up here, not at the origin. This would be our center point. But the graph is way up here. I know that has to be wrong. Okay, so we're looking at 3 of the 4 options left. We've already eliminated 1, so we're looking good as we figure this out. So what do we know here? We know we're starting at the origin, so that's good. We also know that our rate, or our constant of variation, also our slope, is this 8 number. So that means for every 8 miles that we go, 1 hour should go by. This is our slope, or our m value, is 8 over 1, and that's 8 miles each 1 hour. So we should track these graphs and see which one, when you move over 8 miles, does it go up 1 hour? Or when you move up 8 miles, does it go over 1 hour? So let's look. Here, if I go up 8 miles and go over to 1 hour, that should be up here. This graph is much flatter than that. If I went over to 2 hours, it should now be up at 16, because that's 8 times 2. And this graph is much flatter than that. So I know A looks very wrong to me. If I go to B, if after 1 hour, how far should we be? 8 miles, right? So 1 hour, am I up at 8? Well, 8 would be about here. And notice this graph is only at 5. That looks very, very low. Let's double check. So after 2 hours, if I double this, how far any miles should I be? Well, 2 hours would be 16 miles. So we'll go up to 16. Notice again, this is still too low. If I did 3 hours, 8 times 3 would be 24. So I'd be up here. And still we see it's getting further away from where it's supposed to be. B does not look right. So let's hold off on that as we check the other solution, C. So 8 miles in 1 hour. So 1 hour, about 8 miles. That looks right. 2 hours would get us up to 16. This is a shade above 15. That looks perfect. 3 hours would get us to 24. Am I just below 25? Yes. Okay. And 4 hours would be at 32. So am I a little bit above 30? Yes. So answer choice C looks, everything is right on the line what we would expect based on the slope. B, we already said, was too low. So A, B, and D are all out. So what do we know has to be our solution for this one? C. C has the right slope and it goes to the origin. Those two things we have to know for these types of problems. Always remember, with this direct variation stuff, anytime you see that, it will go through the origin. That is the middle of your graph. Use that to your advantage to solve these problems. So double check, and C is it. As we progress to one more example to look at with a little bit of context. So based on the equation we already talked about from the previous problem, we want to know how many hours would it take to jog 16 miles. So our equation is D equals 8H. So let's bring that over as information to make this possible for us to solve. Distance equal to 8 times the number of hours. So we want to find out how many hours. So we're going to solve for H. Would it take to jog 16 miles? So this 16 miles is a distance. So they gave us a distance to plug in, and then we're left with only one unknown, and we'll solve for that H thing. So distance is 16 miles. We'll plug that in. Let's switch colors. 16 for D equals 8 times, we don't know how long that would take, but we can find it. So given that, there's only one thing left to do. We want H by itself. It's attached to this 8 by multiplication. So to get rid of it, we do the opposite of multiplication. So we will divide away 8. And we do it to both sides, of course. So over here, these cancel out. That's just 1. We get just H. On the left, 16 divided by 8 becomes a very easy number. 16 divided by 8 goes into 8 twice. So H, which is hours, it would take 2 hours to go 16 miles at this rate of 8 miles per hour. So looking at our choices, it can become very clear. Our solution must be D, 2 hours. So you should feel confident with these problems. Direct variation, remember, we'll go through the origin. Always origin. Which is the middle of your graph. Use that to help you solve all of these graphing problems and equation problems as well.